Hi, my name is Jagadeesh. I'm a front-end developer and I have around 15 years of experience. And right now I'm working for a startup based out of Silicon Valley. It's called Functionals. In Functionals, we are building a agentic framework that will help companies with their STLC, whole STLC process, not just coding or designing the whole thing. Um, and today I'm going to discuss something about building offline first React apps. So we'll start with the agenda, what is going to happen the next 30 minutes or next 29 minutes. So a little bit of, not explanation, but I will say refresher because you already know what an offline application is. So we'll discuss that first. And some of you would have thought about progressive web apps when you heard about this topic. So we'll see what makes it different and what are the nuances, or like what are the core concept that makes an offline first application and how we can actually implement it. Like what is the stack behind it? What is the idea behind it? So we'll discuss that first. And if we have time, we can see uh, a couple of demonstrations. I do have one, but based on the time, we can do some coding if possible. And yes, once you have an idea of what these type of applications is, you don't have to go and do it from scratch because we always have libraries, and I'll give you some idea about the libraries. So that's the agenda for you. The agenda for me is to give a really captivating talk so you all go home and, sorry, not, my agenda is not to give a captivating talk, and I'm not expecting you to go home and start building an offline first application, but rather introduce you to what you have seen already. And over the course of the talk, if you have a gotcha moment like, oh, right, this is how it works, then I will consider that as a win. So give me a win. All right. Let's go to the basics. What is a offline first application? So in simple words, we as front-end developers or web developers have this primary starting point, right? Like we create applications that works on the internet, and an offline first application flips it. So it is where your application works even without internet, and when there is internet, it syncs, and then it becomes a full-fledged application. So there there are few features that set it apart from your regular applications, and one of them is caching, not just assets caching, but also caching the network, caching the request, and sometimes even the responses. Uh, okay, that seems a bit confusing, right? Like, why would people want to build an offline first application? Because uh, yes, it works on the internet, but we may not have internet all the time. Like we might be sitting in a train and loses the connection, or it's raining outside and your BSNL is not providing activity. It is no more an invalid use case. Back in the time when your tester cannot pull the plug off your internet and say, hey, this is not working and raise a bug. But now they actually can do, because not having an internet is not an excuse. That's why we are in an age where we do not give anything to, no, there is no such thing as a natural calamity when it comes to internet. You handle it no matter what is thrown at you. So yeah, this is what we discussed previously. So the data is your starting point. Data is processed locally all the time and is synced whenever you have connection. So this way, you can let your user do anything you want. The whole CRUD thing. They can read, they can write, they can delete, edit everything, and they don't need to worry about the presence of internet. And you sync it later. And yeah, offline first apps is not something very new. We have seen a lot. I do have a slide for that. Uh, but if you have a question like, okay, I hear you, but you're just describing a progressive web application. In a way, yes, I am describing a PWA, but there is a slight difference. When you build a PWA, you make that application have local app-like capabilities, right? Which means it works in an offline scenario as well. So what is offline first? So offline first is rather a design approach. In a PWA, you strive to provide a native like experience, and offline is not a first feature. It is rather like a fallback. But when we build a offline first application, the default mode itself is that you consider that there is no internet, and then you sync it. You sync all the actions when there is internet. So building an offline first application is or could be a part of PWA, but not the other way around. So I'll give you an example. When you use Swiggy, not the app, but the PWA, it has to be on and all the time, or else there is no point in having a Swiggy app, right? But let's say you are using a Google Docs in offline mode. It can still work offline. You can make edits, you can make all the changes, but when there is an internet, you can sync it. So this is how you can differentiate where you want to build a proper PWA and where you want to build just an offline first application. And yeah, few examples to just refresh your memory. WhatsApp web is a very good example. Even if there is no internet, you can still scroll, look at your some of your chat history, not all of them, send messages, and whenever you get internet, it will the timer icon will turn into a single tick, double tick, and a blue tick. And Google Docs, we use this every day. At least some of us use this every day. Uh, Interesting thing is your Google Doc is not always connected to the internet. So whenever you make any changes, when it makes an auto save, or when someone else who is collaborating, that is when it actually requires the internet. Other time, it actually works like an offline application. And Notion is one more example. Basically, Notion and Google Doc may have similar architecture. Linear is another example. So there are so many offline first applications that we come across in our life, and sometimes we don't even realize that. But like, why so much first? Why is this so important that this is actually a topic in this meetup? Uh, to give a small example, I'll show you this. Um, okay, this is not like a huge application. It's a very simple notes, and I can create a note and save it. So yeah, I know this is not a complex one, but let's see what happens when I make it offline. Right? So here I'm trying to create a note. So this seems to be working fine. I can make some changes. But when I try to create something, nothing happens. Some of you might say like, hey, in this scenario, I can throw an error. Like it could be a console.error, or it could be a model saying like, hey, something went wrong. But as a user, I am annoyed. I mean, like, not me. But in real time scenario, I understand that this application has a complexity that is like 1/100th of what you create in daily basis. But if your user is annoyed, I'm sure that user is 100 times more annoyed. You can see that the networking is making requests, but nothing is happening because there is no internet. I try to delete it. It is not deleting. I try to edit it. It's not editing. You may find this crazy because if there is no internet, it may not work. It cannot work. But what if we flip the script and say if there is no internet, it should still work? And that, my dear friends, is what we are going to talk about. And that is why offline first is important. Um, so far, any questions? I know we haven't really dived into the topic, but if you have any questions, we can discuss, or else we can go to the end, and or we can discuss offline. All right. So what makes an offline first application? So it can follow. There is no single rule or there is no single library to make your application offline first, or your application works when there is no internet. But there are a certain concepts that you can follow. So the first thing is caching. When we say caching, we are talking about caching using a service worker. So Service worker is a let's say it's a separate process that is independent of your web application, your main page. It can run on a different CPU, and it can do work for you, similar to web worker. But service worker can actually mess around with network and request, which means whenever we make a request to the internet, we can use service worker to cache it, to have a copy of that. And not just request, we can also cache responses. So we can put versioning to the responses, and we can use them this way. Not only we create offline first applications, but we can also speed up or just show the user that your application is faster. So it starts with introducing caching, and to introduce caching, we use service worker. Next step is to use a local database. So whenever there is a change in your state of your application, you don't immediately throw it to the internet. You maintain a local database. Most of the time we use IndexedDB. Uh, some people also use local storage or session storage. And there are also a lot of wrappers for that. But the idea is to use a local DB. So you cache your network request, you cache some of the responses, you maintain a DB in your local, and now these 2 points are sorted out. And the next thing is synchronization. So synchronization is basically when you are between online and offline scenarios, you figure out, oh, till point A, I have completed my request and response with the server. Till point A to point B, I was offline. So I have some changes, but I have those changes stayed in my local state, saved in my local state, like my index DB. And then when I get back online, I sync it straightforward. But this could get complicated when you are using collaboration. So let's say like uh, user A is working on the application, and then I'm also working on the same application. We hit the database at different times. We have other ways like we can decide which data should go, but a data should go. It should get synchronized, and that synchronization happens in the background. And in this world, we popularly it is called as background sync. And the most important part of background sync is the conflict resolution. Um, so there are three major ways that people do it. They go with last right wins. Whoever uploaded last, that will perish. Very easy, but it's not a very good move because the other person is going to get annoyed. Or we can use merge algorithms. Merge algorithms we see on daily basis. On every day we merge. We have conflict with our GitHub code. So similar merge algorithms are used. Or user intervention, like you just show the user, hey, this is what is happening. So what do you want me to do? So once the conflict resolution is done, uh, you once these three layers are implemented, that's when you have an application that can actually behave like a normal application, not just fall back, behave like a normal application even when you don't have any internet. Uh, One thing which I forgot to mention here is showing the user, telling the user that there has been a change. So you detect whether you are online or offline, and then you show the user that in UX, because I told you, right, this is a design approach that, hey, you are offline. So whenever you are coming online, we'll queue the changes or sync the changes, or your changes are not synced. So I'm sorry, like I messed up. So you have to go back and do some more changes. That's up to you. Okay. How is this actually implemented? The first part is by using a service worker. So uh, the first part is registering your service worker, letting the browser say that, hey, I have a service worker. This is the path. So whenever you run this, please activate my worker. So once it is activated, you can define what are the networks that you can fetch and put it in a cache. I'll show it later where it is getting saved. But the first thing is to strategize what are the APIs that I need to cache. You can cache your network request. You can cache your uh, assets, background images, and everything. Have you seen YouTube without internet? When you don't have internet and go to youtube.com and press enter, it does not show the dinosaur page, right? It actually shows some header with all the right navigation, left navigation, and I think some of the downloaded items. So how that happens is, first time when you're on YouTube, the service worker will cache certain assets, certain static resources, and certain requests. So when there is no internet, your service worker will use that cache and serve it in your client and give you an idea that, hey, we are not completely broken. In the center, it will say the internet is not working. So basically, they delegate that we are not, the mistake is not on us, it's on you. But it gives a very good experience, right? Like rather than seeing a broken page, I would happily see a page that says that you don't have an internet. And that is achieved using service workers. And the second thing is here, I'm saying index DB. A lot of people will use Pouch DB or Watermelon DB, uh, but eventually they are actually wrappers of index DB. So why index DB? One thing is like it's a low layer, it's a low level client API for your browser to store data, and the best part is the cutoff data. The cutoff for your index DB is 50% of your computer's memory. So if you are having a 512 MB, 512 GB space, half of that is actually something that your IndexedDB can use, which means like you can save enormous amount of data. That is why Google Docs is running seamlessly in your laptop even when there is no internet. So you use IndexedDB. All the data that you collect that are going to be served in your application as a state, you can organize them and you can sync them whenever you want. And yeah, the network detection and sync is another important part. This is normally done by the Navigator Online. Sometimes they can be very unreliable. So your Navigator Online will only check if you are connected to a network or not, not to the internet or not. So ideally, I mean, the simple thing to do is using Navigator Online. Some people, they will have a heartbeat kind of system. It could be WebSocket or it could be your SSE. So if there is heartbeat, then yes, the internet works. Or if there is no heartbeat, then you show the user that, hey, you are offline, but don't worry about it. You can still work. And since this is a React meetup, I also included React hooks, but this part is completely optional. Um, this is mostly to give your code a cleaner approach. Like you write hooks and use them anywhere you want. For example, I showed the notes example, right? So I'll just create a hook for my notes, and that hook will internally talk to my IndexedDB. It will take care of syncing, and all I need to do is just call my hook to save my notes or delete my notes or edit my notes. On a different application, you can use the same main file, but just remove your hook if you want to remove your offline capability. So it works either ways. Right. Okay, so far so good, right? I mean, this looks really good, but it doesn't mean it does not mean that I can go home and make all of my applications uh, offline first. I said go home because I work from remote. In your case, go to your office. It's up to you. Uh, the first thing or the most general thing is building an offline first application is such a huge power because we are conditioned that when you have internet, it works. When there is no internet, it does not work. Now we are changing the whole scenario, which means that that's a huge power. And with huge power comes huge, huge EB bill. Means like you can't simply create everything offline because you are going to use a lot of space in your local machine. You are going to cache like almost everything that is being served. That does not make any sense. So the first thing to question yourself is like, what do I need? Like uh, offline first is not a fallback. It's a feature. So do you really need that feature? Because you will be spending a lot of energy and time on building those features. And whenever your application scales, those features have to be supported. So that's the first question you should ask. Do I really want this? And the second thing is storage limits. Yeah, I know I said that you can use your IndexedDB to have it supports up to 50% of your storage, but you are not going to use your computer purely for your browser work. Like you are going to store some applications. I think Google Chrome itself is 2 GB. You're going to save videos. A lot of things are going to happen, which means you will never know how much space is going to be there in your client's machine. So that has to be calculated. And if it is not worth the risk, there is no point building an application which has offline first capabilities. And the most important issue is conflict resolution. Like conflicts are bound to happen, especially when the app is facing multiple users and it's like super data intensive. Is it going to be simple? Is it going to be easy? For example, at one point of time, I was working on a Google Sheet with 200 logged in users, and it simply crashed. So if I'm not saying 200 people is limit, but for Google, 200 should not be a great number, but it still happens because it's resource intensive. And when a lot of people are logged in, it is almost close to impossible to resolve all the conflicts. So that's another question to ask, how easy my conflict resolution is going to be. And yeah, testing challenges. So once upon a time, testing your computer, testing your app when there is no internet was not even a use case, but now it is a use case. This opens up like a huge range of opportunities for the QA. I mean, they're practically, uh, they will write 100 test case if you just tell them, hey, my application is going to work on offline. But that is so true. Like if you have offline capabilities, is it going to work on a 3G? Is it going to work on a 4G? Or if it's a good tester, the tester is going to ask, is it going to work on a 2G? So when I say offline, what happens if my page is not served over the internet? So let's say that I have a page abc.com and my API is from xyz.com. If xyz is down, if my application is offline first, it will still work. But if the whole internet is down, I'm not even going to hit abc.com. So what happens at that time? The the test cases are like practically infinite in this scenario. So what is your strategy? Those are the questions you can ask yourself when you are trying to, like build a application with offline capabilities. I don't mean it as a threat. It is not that complex. At the same time, it is not something that you should take it easily. Okay, yeah, this is my favorite part. So you don't have to do everything from scratch, right? I know you don't do everything from scratch. You use Cursor to do that, but we do have a good range of libraries to implement all these design approach into a system. And it starts with Workbox. Workbox is probably the most famous, uh, I don't want to say library because it's a set of tools that is an offering from Google Chrome that you can use to build your PWA applications, which means they offer a lot of modules that you can just take it and put it in your application and make a good offline first application. And Dexy.js is my favorite library. It's basically a wrapper for IndexDB. IndexDB itself is like very simple, but Dexy makes it even more simple. It gives a verbose like command. So like when you just install it, you will know what to do. It is basically a await promise based wrapper that you can put it in your application, and it does not by itself give you an offline capabilities, but you can use Dexy to create a good index DB management. And React Query and SWR are like pretty famous again. React Query is in I think it's Tanstack now. So what they do is they provide support for data fetching. At the same time, they also sync with your local storages. So you have offline capabilities for most of your requests and responses. And they also handle sync. Uh, I forgot the model name, but yeah. PouchDB, RxDB, Watermelon DB is not here because it's not summer. But these are local first databases that you can use. Once again, it is not similar to Dexy, but they are far more advanced than a simple wrapper that you can put it in your application, and it just makes your lives easier. Okay, I have one more demo. So remember we saw this, the previous one, a simple note-taking apps. So just by looking at this, you can see there is one major change, which is I have an indication saying um, the user is online. So what happens when I go offline? I was offline. Okay. So I was first online, so that's why it stayed. Okay, so this is the implementation wise, caching and then storing and then syncing is how it works. But for a user, it starts with a visual indication showing that, hey, you're online, or hey, you are offline, something like this. Okay, let's go offline and let's create a new note. In the previous example, you saw that we were not even able to create a note for a good reason, because no network requests were made. Let's create a offline note here. What happened now is you can see that no network requests have been made, but my UI reflected the state change that I have added a new note. And we are also showing the user, hey, there's a pending change. Don't be very happy. You don't have internet, but we understand that you made a change and we have saved it. And the minute we go online, this gets synced and your notes are saved to the internet. In this case, it is not really saved. This is a fake API, but this is how it works in a real-time scenario, right? Let's look at the index DB. So here I have my notes DB, and you can see that I'm saving all these items here. Let me go offline quickly once again. And let's add one more. So you can see that I have also a sync queue DB. So this is where I store the items that are not saved. And every time there is a change from offline to online, I will check this QDB and I process that DB, and then it gets saved into the notes DB. Okay. And okay, it makes sense. The sync DB makes sense, but why do we have a notes DB? Um, this is just like a layer where when we load the application for the first time, we pick it from the notes DB and then we show it. And then we make a request to make sure that whatever is there in the server is also in the client. And once it is done, once it is synced, uh, whatever is there in the server is also in my notes DB, which means I show that in my state. That's one flow, right? The other flow is whatever is there in your local, in your state, but not in your server, that stays in the sync DB. So we constantly bridge the gap between online and offline, between the server and the your client state. And that's pretty much it. That's how you make it work. This is like a very basic example, but you make it bigger, you get your Google Docs. So yeah. Yeah, well, that's pretty much it. Um, we do have 4 minutes, so if you have any questions, I'm happy to answer.